Hello friends, good morning to all. I hope I am audible to all the students. Okay, fine. Thank you all. So friends, if you remember in the last lecture, we have completed the first chapter of the subject of basic mechanical engineering. That chapter was very easy chapter and one of the scoring chapter in the subject of BM. I hope you have understood all the points of the first chapter, that is the introduction, and you can score good marks in that chapter. Dear friends, I was getting many queries from your side related to the textbook or the reference book for the BME. So before starting our today's session, this is the front page of the reference book for the basic mechanical engineering. Remember friends, whenever you are purchasing, you need to see the title of the book. You need to cross check the authors. The name of the authors are H.G. Kataria, J.P. Hadia and S.M. Bhatt. And the publication, that is the Books India publication. This is the latest edition 2019, that is the latest edition which is available in the market right now. But if you are getting any other previous edition, as for example the 10th edition or the 9th edition, then also it is okay. You can purchase that book also. But friends, remember, once again I am telling, Basic Mechanical Engineering by H.G. Kataria, J.P. Hadia and S.M. Bhatt, the publication needs to be compulsory, the Books India publication. I hope I have cleared the doubt related to the purchase of the textbook, because this question was asked by several students. I want the responses from the students in the chat box. I hope now you are clear about the textbook for this subject of basic mechanical engineering. Okay, I am getting the responses from the students. Okay, thank you all. So now friends, let us move further to one of the important chapter of this subject, that is the third chapter, and the chapter name is the properties of the gases. Dear friends, this is one of the most important chapter if we consider the theoretical examination, because in the theory examination several questions are asked from this chapter. Properties of gases, the complete chapter is a totally analytical chapter. In this chapter we are going to derive several equations, several expressions we will be deriving, and finally after the discussion of all the analytical points, we will solve several numericals in context of the properties of the gases. So before starting today's session, let me suggest you that you keep a writing book and the pen with you, so that you can also do the derivation as I am explaining the steps, so that one by one, if you are noting down all these steps in your book, then the concept will be perfectly clear in your minds, and in the exam you can write the perfect answers. So I hope you are ready with the book and the pen, and for solving the derivations which we are going to discuss in this chapter. So let us proceed further in the today's session. So these are the main contents of the discussion of the current session. First, we are going to understand some of the basic concepts of the gas. Then we will understand the concept related to the perfect gas. And we will understand the different gas laws. And finally, we will understand the conditions such as the NTP conditions and the STP conditions. Rule number 14, Kalp Trivedi, are you getting my voice? Okay, fine. So friends, let us start with the discussion. Kalp Trivedi, are you getting my voice? All the students are requested to off their videos so that no disturbance is being created during the lecture session. So try to maintain the decorum because all these things are recorded and will be published, as you are aware, in the YouTube links. So let us start with the first point, that is the gas. Dear friends, you are well aware that we are having three states of the matter of any substance, that can be the solid, liquid and the gas. So gas, if we consider, it does not have a definite volume. The gas, it always takes the shape of the container. Generally, if we consider the parameter of compressibility, then gases are considered to be the most compressible as compared to the solids and the liquids. Since the gases are having the larger intermolecular spaces, we can easily compress the gas as compared to the solids and the liquids. The most and the remarkable property of the gases, however, they all behave in the same way in response of the temperature and the pressure conditions, or the changes in the temperature and pressure, or whenever we are doing the expansion or the contraction processes on the gases by some predictable amounts. That means within the boundary conditions, all the gases generally they behave in the same response. If we consider a microscopic level or the macroscopic level for understanding the properties of the gases, a complete or physical description of the sample of the gas always requires four quantities. Remember friends, these four quantities are very important and continuously we will be discussing all those four quantities throughout the lecture. The four quantities which are used for the physical description of the sample of the gas includes the first one, that is temperature, which is denoted by capital T. Next is the volume, which is represented by capital V. Third one, that is the amount of the gas, which is denoted as small n, and it is generally expressed in the moles of the gas. And finally, the fourth parameter, that is the pressure, and it is denoted as P. So these are some of the basic understandings related to the concept of the gas. Moving further with the next topic, that is the perfect gas. Dear friends, a perfect gas in engineering terms or in mechanical engineering terms, it is generally referred to as an ideal gas, because this gas in its physical behavior perfectly obeys the ideal gas laws. And since this gas obeys the ideal gas laws, it is known as the ideal gas or the perfect gas. If we consider the definition according to your textbook or the reference book, the perfect gas may be considered as the gas that obeys the Boyle's law and the Charles law under all the conditions of temperature and pressure. Generally, friends, if we consider the practical approach No gas is a perfect gas. All the gases are considered as the real gases. But for the analysis point of view, for finding the properties of the gases, we are assuming the real gases to behave like a perfect gas. So now you will understand the third statement. There is no gas which is perfect, but many gases such as hydrogen, oxygen, nitrogen, air, etc. may be regarded as the perfect gas. Only the gases are considered to be perfect gas in order to study the properties of the gases. But practically all the gases are termed as the real gases. Moving further with the next topic, that is the gas laws. Dear friends, the gas laws are a group of laws that govern the behavior of the gases by providing the relationships between the different parameters. The different parameters can be the volume occupied by the gas, that is the capital V, the pressure exerted by the gas on the walls of the container where the gas is filled. The third can be the absolute temperature of the gas, and the fourth one will be the amount of the gaseous substance or the number of moles of the gas. So the gas laws, they give us the relationship between all these four parameters. The gas laws were developed towards the end of the 18th century by numerous scientists, after whom the individual laws are named. Dear friends, I hope that you have studied some of the gas laws at your school level. So let me ask you if you remember any of the gas laws which you have studied. Can you name any of the gas law which you have studied previously? Okay, some students are telling me the Boyle's law. Okay, Boyle's law, that is the answer. Charles law. Okay, rule number 28. Okay, Gay-Lussac law, Charles law, Gay-Lussac law. Okay, fine. Very good. So majority of the students are well aware about the gas laws. So let us discuss the gas laws one by one. So the first one, that is the simplest one, that is the Boyle's. Dear friends, if you want, you can note down these equations also, because in other derivations we'll be using all these concepts, all these equations. So Boyle's law, it states that at constant temperature, when the pressure on the gas increases, its volume decreases. So in other words, according to the Boyle's law, we can tell that the pressure is inversely proportional to the volume when the temperature and the number of the molecules are constant. So this is an important characteristic of the Boyle's law. In the Boyle's law, the temperature as well as the number of molecules present in the gas are considered to be constant. So considering the statement of the Boyle's law, understanding the statement, we can write down in the mathematical form such as P is proportional to 1 by V. Removing the proportionality sign, we are using the constant. So thus we can write down P is equal to C into 1 by V. On rearranging the terms, we can write down C is equal to P into V. That means for the Boyle's law, the product of pressure and volume remains constant. So now understanding this point on the basis of the PV diagram, I am taking a PV diagram, initial state that is 1, final state that is 2. And you are seeing on the PV diagram, the system moves in the process that is 1 to 2. At 1, we are taking the values P1 and V1 respectively for pressures and the volumes. And similarly, we are taking the values P2, V2 for the pressures and the volumes at the final state that is 2. So friends, according to the Boyle's law, considering this process 1 to 2, we can easily note down P1V1 that is equal to P2V2 that is equal to constant that is C. Or in simple terms, P initial multiplied by V initial is equal to P final multiplied by V final that is equal to constant. So considering this equation, now we can write down the standard equation of the Boyle's law, that is PV is equal to constant. So I hope you are getting all the points. I hope that you have already studied, because majority of the students has given me the answer of the Boyle's law when it was asked about the names of the gas laws. Please send me your responses in the chat box. Are you understanding the simple points of the Boyle's law? Okay, fine. Getting the positive responses as always from the students. Thank you all. Moving further with the next law, that is the Charles law. So Jack Charles in 1787 analyzed the effect on the volume of the gaseous substance at a constant pressure. He did this analysis in order to understand the technology or the concepts behind the hot air balloon flight. So according to his findings, Jack Charles told that at constant pressure and for the constant mass of the gas, the volume of the gas is directly proportional to the temperature of the gas. So in the Charles law, we are taking pressure to be constant and the mass to be the constant. And according to the Charles law, volume is proportional to temperature, directly proportional. So we can write down the equation V proportional to T. Thus, removing the proportionality sign, we can write down V is equal to C into T. On rearranging the terms, we can write down C is equal to V upon T. So now let us understand on the basis of the PV diagram. So this is the PV diagram. For the Charles law, we are seeing that the pressure remains constant at initial state 1, final state 2. According to the Charles law, we are writing down the equations. V1 by T1 is equal to V2 by T2, that is equal to constant. Same as what we have done the method in the Boyle's law. The initial conditions is equal to the final conditions. So indirectly we can note down C is equal to V by T. Moving further with the next gas law, that is the Gay-Lussac's law. The Gay-Lussac law gives the relationship between the temperature and the pressure of the gas. But here we are considering at constant volume conditions. So this law states that at constant volume, the pressure of the gas is directly proportional to the temperature of the gas. So according to this statement of the Gay-Lussac law, we can write down mathematically, that is P is proportional to capital T. Removing the sign of proportionality, we can write down P is equal to Ct. On rearranging the terms, now we can write down C is equal to P by T. So this is the simple understanding related to the Gay-Lussac law. Moving further with the next gas law, that is the Avogadro's law. So according to the Avogadro's law, at constant temperature and pressure conditions, the volume of all the gases, it constitutes an equal number of the molecules. So this law gives us the relationship between the volume and the number of molecules. In other words, this implies that in the unchanged conditions of temperature and pressure, the volume of any gas is directly proportional to the number of the molecules of the gas. So if you have understood the statement perfectly, mathematically we can note down V is proportional to N. Thus we can write down V is equal to C into N, where N represents the number of moles of the gas. The number of molecules in a mole of any gas is known as the Avogadro's constant. So here let me ask you the question. Anybody is knowing the value of the Avogadro's constant? Any student is knowing the value of the Avogadro's constant? Any student, if you remember the value of the Avogadro constant? Okay, some of the students have given me the answer. Okay, you can write down the answers in your chat box. Okay, majority of the students has given me the answer perfectly. Some of the students are confused in the answer. So the perfect answer of the Avogadro, that is 6.022 into 10 raised to power 23. So just for the knowledge, you can note down this point, the value of the Avogadro's constant. So dear friends, let us proceed further with the next topic, that is the combined gas law. And dear friends, this is one of the important question which is asked in your examination. So as I am doing the derivation, you can also do the derivation as I am explaining all the mathematical steps. So let us understand some of the basic points of the combined gas law. In practice, the pressure, volume and temperature of the gas, they all change at the same time. As the pressure changes, we cannot apply the Charles law, and as the temperature changes, we cannot apply the Boyle's law. So now it is necessary to combine these two laws in order to understand the final conditions of the gas. So according to the combined gas law, we are using the PV diagram. So if you want, you can also draw the rough sketch in your book of the PV diagram, because the complete derivation we will be following this PV diagram. So moving further, now we are considering mkg mass of the perfect gas to change its state in two successive processes. The first process we are considering, that is process 122, which is taking place at constant pressure conditions. And next we are considering process 223, which is taking place at constant temperature conditions. So friends, for process 122, which gas law we can apply? The process 122 at constant pressure, which gas law we can apply? Charles law. Okay, very good. That is the perfect answer. So on applying the Charles law, now we will be getting the equation. That is applying the Charles law, we are getting the equation. V1 by T1 is equal to V2 by T2. Initial state is equal to the final state, because the P remains constant. I hope you have understood this point. Moving further, since 2 to 3, that is taking place at constant temperature, the temperature remains constant. So I can write down T2 is equal to T3. So substituting the value of T2 by T3, we are getting the equation, that is V1 by T1 is equal to V2 by T3. I am replacing the term T2 by T3 according to the PV diagram. So again moving further, making V2 as the subject of the equation. So I am writing down the equation, V2 is equal to V1 into T3 by T1. And I am marking these as equation number 1. I hope you have understood up till here. The concept is clear to all the students, very simple to understand, and if you are noting down, then you will perfectly get the confidence in making the derivation. Moving further to the next process, that is process 2 to 3. So in process 2 to 3, the temperature remains constant. So which law we can apply? The Boyle's law or the Charles law? So for process 2 to 3, which law we can apply? Boyle's law or the Charles law? Okay, very good. Perfect answer from majority of the students. We can apply the Boyle's law. So applying the Boyle's law, now we can note down the equation. That is applying the Boyle's law, initial states is equal to final state. So I can write down P2 V2 is equal to P3 V3 because temperature remains constant. Now again for process 1 to 2, I am having pressure to be constant. So I can write down P1 is equal to P2. So in place of P2, I am substituting P1. And now making V2 as the subject of the equation, I am getting the new equation, that is V2 is equal to V3 into bracket P3 by P1. That is my equation number 2. Now from equations 1 and 2, we are having the same values, that is V2, V2. So combining both these equations, writing down the answers. So V1 into T3 by T1 is equal to P3 V3 upon P1. I hope you are understanding the points. Now taking one number on one side and the 3 number on the other side, rearranging the terms, we are getting the answer, that is P1 V1 upon T1 is equal to P3 V3 upon T3. So friends, for this complete process starting from 1 to the final process, that is 3, we are getting the equation P1 V1 by T1 is equal to P3 V3 by T3. That means the initial conditions are equal to the final conditions. So now I can easily note down this equation, that is PV upon T, that is equal to constant. And this equation is known as the combined gas law, because in this equation we are observing in the same relation we are getting the 3 parameters, that is pressure, volume and temperature. So I hope you have understood this derivation perfectly. The steps are clear in your minds. Moving further with some other steps of the derivation, again taking the equation PV by T is equal to constant. The magnitude of this constant depends upon the particular gas. And this constant is denoted as capital R, where capital R is known as the characteristic gas constant. So constant capital R depends on the characteristics of the gas, the properties of the gases. So all the gases will be having the different values of capital R. If we are considering m kg mass of the gas, so I can write down PV by T is equal to m into R, where m is the mass of the gas in kg. So this equation, I hope you have already studied at your school level. You are well aware about it. That is PV is equal to mRT. That is the equation of state for a perfect gas. And dear friends, this is a very important equation we are going to use several times when we will solve the numericals of the properties of the gases. So remember this equation, PV is equal to mRT, where P represents the pressure of the gas, V is the total volume of the gas, M is the mass of the gas, capital R is the characteristic gas constant, and T is the temperature of the gas. So now if we are dividing the volume by the mass, dear friends, can I divide the pressure by the mass? Is there any effect on the pressure? Can I divide pressure by the mass? Is there any effect of pressure in context of the mass? Any student? Okay, 25 perfect answer. No, no. Okay, 32 has given also me the answer, and he has also justified the point. No effect on the pressure, because the pressure is an intensive property. That is a very good answer, the perfect answer. Because the pressure is a type of intensive property. So if we divide by mass 1 kg, 1000 kg, 1 crore kg, there is no effect on the pressure. But there will be the sure effect on the volume. So I am dividing the mass in context of the volume. So now if we are dividing by the volume with the mass, then we are getting a new term, that is small v. And this small v, it represents the specific volume. So the unit of the specific volume will be meter cube per kg. And the new equation now which we have got, that is PV is equal to capital R into T. This equation is known as the characteristic gas equation, where the notations are V stands for the volume of the gas, already explained in meter cube. P is the pressure of the gas, we are considering it to be in Pascal or Newton per meter square. Temperature, we are considering the temperature of the gas in Kelvin. And capital R, that is the characteristic gas constant, which is taken in joule per kg Kelvin. So I hope you are getting all the points, you are understanding the new equations, how we are deriving the newer equations, and what are the names of the equations. Moving further, now we are using the equation, that is PV is equal to R, where V stands for the specific volume. So now, multiplying both the sides of the equation with the molecular mass of the gas, that is capital M. So multiplying capital M on both these sides, there is no change in the equation. So we are getting the equation capital M into PV is equal to capital M RT. Let us mark these as equation number 3. Now we know that M into small v, that is equal to V mole, that is the molar volume of the gas. In simple terms, it is the volume occupied by 1 mole of the gas. I hope you have studied all these points at your school level and you are remembering all those points. And capital M into R, that is the product of molecular mass and characteristic gas constant, that is R0. And R0 is known as the universal gas constant. The value of R0, that is 8314.3 joule per kg mole Kelvin. Dear friends, remember this point, the universal gas constant, the value is fixed constant for all the gases, but the value of R characteristic gas constant will be dependent on the characteristics of the gas. So the value of R will be a variable parameter, but the value of R0, that is constant for all the gases. Hence we have given the name of R0 as the universal gas constant. So I hope you have understood this point up till now. So substituting all these values which we have derived in the equation number 3, now we are getting the answer, that is P into V mole is equal to R0 into T, and this new equation is known as the Clapeyron-Mendeleev equation of this thing. So this is the final equation which you need to remember in the derivations of the combined gas law. Dear friends, whenever you are asked in the question, just understand the question, which is the type of the question you are asked, and accordingly you have to write down the answer. If you are asked to derive PV is equal to MRT, then you have to follow that particular procedure up till the final answer. If you are asked the combined gas law, then you can derive PV by T is equal to constant, that is the combined gas law. I hope the picture is perfectly clear now in your minds. And this important question, the derivation, the steps of the derivation, you have understood perfectly. Moving further to the last point of this session, that is the NTP and the STP conditions. NTP stands for the normal temperature and pressure, in which the pressure value is 101.325 kilopascal and temperature is 0 degrees Celsius. But when we consider the STP conditions, that is the standard temperature and pressure, the pressure value remains the same, that is pressure is equal to 101.325 kilopascal, but the temperature value is changing, so temperature that is 25 degrees Celsius. So these are the simple understandings related to the NTP and the STP conditions. So friends, with this I am concluding the session from my side. Thank you for watching the session. Have a nice day. Now the session is open for the doubt solving. If you are having any questions, any queries or any doubts related to the current session, you can ask me in the chat box. Let me instruct you or let me inform you that by today you will be getting the questions of the assignments of the subjects, and in the next lecture, in my next BME lecture, we are going to discuss how to write down the answers of those questions. If any student is any question, any doubt, you can share in the chat box related to the topics we have covered in the current session. Okay, 32 number has asked me the question, are the equations PV is equal to MRT and PV is equal to NRT different equations? Yes. Rule number 32, both the equations are different because the capital M, that is the molecular mass we are considering, the unit is different, and N represents the number of moles of the gas. Both are having the different terminology, both are having the different descriptions, and in both the equations also the volume is also having the different units. I hope I have answered your question. Rule number 32. Combined gas law, it is the derivation in which we are combining the Boyle's law and the Charles law. We are taking two processes, process 1 to 2 at constant pressure and process 2 to 3 at constant temperatures. Then we are noting down the equations. For first process, making V2 as the common term, deriving the equation. Again for next process, we are taking V2 as a constant term, deriving the equation, and finally we are combining these equations and we are getting the answer. P1 V1 by T1 is equal to P3 V3 by T3. That means the initial stage is equal to the final stage, and hence we can note down PV upon T, that is equal to constant. In this equation all the three parameters are combined, so it is known as the combined gas law. Any other questions from any student if you want to ask? Okay, thank you. Rule number 3 for the response. Okay, let me ask you, all the students, have you noted all the equations in your book? Are you writing down the equations and the derivations which I am explaining? Okay, I am getting the answer from roll number 2. Okay, 69, 16, 33. Okay, 66. 62. Okay, fine. Okay, so majority of the students are noting down. So if we are writing down the equations, I am damn sure that you will be perfectly understanding the derivations. Okay, and this is one of the most important chapter, which is totally the analytical chapter. So if you write down the derivations, understand the steps properly, then only you will be getting the answers. Otherwise, you will be confused in the exam. Okay, students, so I am getting no doubts in the chat box. So thank you all once again. So with this, we are ending the session of today. See you in the next lecture.